I am here to discuss the so-called flying saucers.
We know now that in the early years of the 20th century, this world was being watched closely by intelligences greater than man's.
Did the CIA write Wind of Change by the Scorpions?
As humans busied themselves about the various concerns, they were scrutinized and studied.
Dr. Loeb, what percentage chance do you give it that you have indeed uncovered extraterrestrial or non-human technology?
With infinite complacence, people went about their affairs, yet across an immense ethereal gulf, intellects vast and unsympathetic threw their plans against us.
All of a sudden, a stick out of nowhere landed right in front of us, and there was no tree, nothing overhead. Something threw it at us.
Yeah.
All things unexplained.
So some of that, I think, sir, we'll save for closed session.
Hello, all you unexplained ones. I am CJ Derringer. I am joined with my co-hosts, Dr. Tim Mounts and Smitty. Hello, fellas. How are you?
Hey, what's up, CJ?
How's it going? Pretty
All
exciting
right.
show tonight.
Scale of 1 to 10 out of this universe. How excited are you for our guest?
Definitely a 10.
He's the best.
I mean, based on tonight's content, I would have to say infinity. That would be my scale for tonight. And you know what? We already have some folks chiming in that are pretty excited. Hello.
Hey, we've got our friend Nikki Starchild from Good Morning UFO chiming in. Hey, girl. We've also got UFO Busters, that UFO show Australia, also chiming in. We are so happy to have you all. We would love everybody's comments, everybody's questions. Bring on the enthusiasm. Let's roll, right?
Did you say what they say?
Oh my goodness. Hello, guys.
UFO
Busters. You all love from Sydney and must apologize for our stunning breakdancing efforts at
Did you see that, CJ?
Oh yes. Who didn't see that? Who didn't?
They did Australia proud. Smitty, you got to do your Australian breakdancing accent.
Good day, mate. Let's go do some breakdancing. Oh, it's Kath and Kim. I mean, it was like Kath and Kim. Y'all know what that show is?
No.
It is the best Australian comedy show, but probably one of the best comedy shows of all time. You need to watch it.
Please don't offend our Australian friends.
Yeah.
It is it's a great show, literally.
Oh, we will have to check that out. Well, you know what else is a great show? This one that we are about to do here. For those of you that are joining us, if you have not yet, please do hit that subscribe button, like, and share. And one other thing that you need to do is go buy your copy of the handy quantum physics answer book. We've got a link to it in the chat. This is what we will be discussing tonight with our good friend, Dr. Charles Liu. He has been with us since the beginning of our time. Basically, we have talked to him about everything from physics to Marvel comics to sci-fi movies, and now we're diving into quantum physics, which I owe all of my physics education to Dr. Charles Liu. We call him Chuck. He's a good friend of the show, and he will be joining us right after this commercial break.
Yep. And you know what? I have to say something real quick because Dr. Liu would know. Well, I'm sorry, but Dr. Liu would know what a no prize is, I feel like. And we have a no prize for Dr. Liu tonight because as of tonight, he's officially our most frequent guest.
Yes.
At least I'm pretty sure. DJ from Calling All Beings is up there too.
And Dr. Liu has been with us
Dr.
through
Liu
some
is
serious
higher
tech
up the ladder.
Challenges.
It's like being a 5-timer on SNL.
Yeah.
I know. And every time he comes on with us, we talk after the show and we're like, well, he ain't coming back again. But
he's awesome.
Keeps returning. Awesome. But we have a very special ad first here. This is not just any ad. This comes from our friend Ryan Sprague at Somewhere in the Skies, the Somewhere in the Skies podcast. And he sent this to All Things Unexplained for tonight, just for tonight. And I can't wait to play it for you. And then a little commercial from CJ. All right, here's Ron Sprague from Somewhere in the Skies.
Anomicon is a virtual conference on everything anomalous, live streaming on YouTube, Twitter, X, and on Twitch. Join us on September 1st and 2nd as over 24 speakers give presentations on everything from UFOs and aliens to ghosts and the paranormal, from Bigfoot and lake monsters to witchcraft and the occult. It's all happening at Anomicon. And most importantly, it's completely free. To learn more about our speakers and the event, visit anomicon.com. We'll see you on September 1st and 2nd for Anomicon.
All Things Unexplained is free to watch on YouTube and listen to wherever you get your podcasts. If you would like to support our show, you can visit our YouTube store. Additionally, you can find us on Venmo under All Things Unexplained. Be sure to check out our website, allthingsunexplained.com. All proceeds from the sales of Dr. Mounce's books on Amazon and Audible also go straight to our show. All right, without further ado, it is our favorite human being in this universe, Dr. Chuck Liu. Thank you so much for joining us again.
Oh, thank you for having me, everybody. It's so good to see you all. Thank you, thank you.
So good to see you too. And in the time since we last had you here, you wrote a book, not just any book, a giant book on quantum physics, and I have sunk my teeth into it, and it has been such a joy for me. I have to tell you,
I'm so glad.
To you. Like I said earlier, all of my physics, astrophysics, now quantum physics education have come from you, and you make it so easy to understand.
Oh, I'm honored. I'm so glad. Now I have to make sure I get everything right, which always I try to do, but
I wouldn't know if you didn't.
No, this whole book, my motivation is to show people how cool and fun quantum physics is, but clear too. It's not this sort of mysterious thing that we could never understand. It's all around us. And so this is really a handbook about this quantum physics thing for all of us. And if you're getting it, CJ, and if you guys are all able to get out of it what I'm hoping to put in, say, hey, this is neat stuff, but it's not at all distant. It's part of you. It's at your fingertips. It's in the sunshine. It's all there. Then I've done my job.
Yes, and you do a beautiful job of that, just like you've done in your previous books about the cosmos.
Thank you.
As soon as I started reading it, I thought to myself, gosh, I've really been afraid of this concept of quantum physics. I haven't wanted to touch it too much in our podcast just because I don't know that much. And then you go, wait a second, this is occurring everywhere. Everywhere that we are, everything that we do involves quantum physics. And you really break that down from pretty much the beginning of quantum physics as we know it to really grandiose ideas that come towards the end of your book as well. So let's start at the beginning. Let's talk a little bit about atoms and subatomic particles and how that plays a role in quantum physics.
Okay. Well, a long time ago, more than 100 years ago, people started noticing that we were most likely made up of, not just humans, but like all things, made up of tiny little particles. And we just needed to know what the structures of those particles were. And then we started running into a quandary. Because what happened was that if we tried to apply the physics at the time that we knew, things like orbital mechanics or electromagnetism and so forth, to these itty bitty tiny particles, things that are a millionth of an inch across or smaller, then you would run into contradictions. The physics that we ordinarily think of just wouldn't work. So one example, all of you all have seen in textbooks the atom, right?
Yeah.
An atomic structure. You have a nucleus in the middle and you have electrons zipping around it. Now, that's a great model to think about the structure of atoms. But if you actually do the mathematical calculations, it turns out that if you try to explain their motion the same way that you would explain, say, Earth moving around the sun, or say a small particle swinging around your hand on a string or something, everything would fail. None of those particles would survive even for a microsecond, and our universe would collapse almost immediately. So some sort of physics had to be going on that we didn't understand at that time. And very slowly over time, we realized that that was possible to explain. And because these little tiny objects were measured in small quantities of material, the so-called quanta, the term quantum physics was born. And that's how it all began more than 100 plus years ago.
Wonderful. And I just did a terrible job of introducing you. I feel like because we know you so well, everybody should know you so well.
It's fine. It's 100% cool.
For those of you that don't know, Dr. Charles Liu is an astrophysicist. He's a professor. He has written several books, and he is the host of one of our favorite podcasts, which is The Looniverse, where he talks about everything related to, you guessed it, the universe. So we are so lucky to have you here with us. Okay, so we've broken down this concept of the atom and why it was important to understand them a little bit further. How does that play into our everyday lives? How does quantum physics play into what we're doing at this exact moment?
Well, the basic idea that we remember is that, like I said, we are all made up of these little tiny particles, these atoms, molecules, or even subatomic particles that make up atoms and molecules. Therefore, all of the things that we see sort of on this large scale all happen when you have gazillions, and that's a technical term, right, of little tiny particles all working in sort of concert, in tandem, in a group, so that any individual object can't be well understood or predicted. But when they're together in their billions and their trillions and their quadrillions, they produce things that we see in our daily lives. Even you and I looking, for example, right now at each other through a computer screen, all of the electronics that happen have to happen when individual particles of light interact with magnetic fields or electric fields that create electromagnetic fields, and then somehow go through all of the equipment that we have and show up on the other side. And it happens almost instantaneously. We don't really think about it, but it's there. Every cell phone that we have works on quantum physics. Every electronic device, any laser pointers or things would have lasers inside them. These little tiny things make all the difference. And even the sunshine, the reason the sun actually has energy to give to us all and provide this sort of life-giving warmth on the earth comes completely from the fact that there are quantum processes going on with those atoms and molecules at the center of the sun that allows for nuclear fusion to happen. So every little thing that we have, if we understand the quantum just a little bit, doesn't have to, you don't have to have a PhD in anything like that. But if you understand it just a little bit, then you really understand how the universe works that much better.
Yeah, we certainly take it for granted. I think that every day that we pick up our phones and we get on our computers, we don't think about all of the little micro processing things that are happening and how much really does have to go into these devices that we use every single day. And we're
Right.
talking about just tiny, tiny things that are making it all work. Speaking of tiny things that make it all work, what kind of equipment are physicists using to look at these subatomic particles, to understand them, to study them?
Great question. You can use as simple a thing as a prism of glass. You just have sunlight shining through and it breaks up the sunlight into its component colors. But what happens is if you break it up just right, then you can actually see streaks, not just of color, but of bright and dark lines in the color. And so the spectrum of the rainbow reveals the quantum structure of the atoms and molecules in the solar atmosphere. That's just one example. Now, if you take that, which was done basically a couple hundred years ago by astronomers and physicists, and put it into modern times, what we're doing is we're sending beams of subatomic particles, things that we know that we can control, but they are so small and they're so fast that we have to detect them through not just typical glass filters, but special kinds of structures that allow us to receive that information, decode it, and then come out the other side. We use electronic cameras that literally count photons as little pieces of light come in, say through a telescope or through our detectors or in big accelerators and so forth. Each piece of light has to be detected. And those electronic components are designed specifically to be able to convert whatever they detect into electrical signals, which can then be sent through our computers and our electronic cameras and so forth to make pictures or to make other kinds of measurements. So really a little bit of everything, but they come basically down to some of the real fundamental things that we do all the time. Every time you use a magnifying glass or every time you see a color of the rainbow off a reflector on a bicycle wheel or something, there's quantum at work.
Wow. Yeah, that's really incredible. I feel like I'm just scratching the surface of understanding quantum physics, and I've been, again, reading your book over the past several days. In fact, I read it to my kids last night.
Yay! That's
They
great.
they
Start
wouldn't go
them
to sleep,
early.
so I was like, "Well, listen, I'll read you a bedtime story," and started reading about all of the different people who have played a role in
Yeah.
quantum physics and how many Nobel Prizes. My
Mm.
goodness.
Yep.
So many
One
Nobel
after
Prizes
another after another.
have been awarded. So I was thinking the whole time, I'm going, okay, there's all these great people who have discovered things, who have done one more than the person before them, taken it one step further in understanding. Is there anything you're currently working on that's going to get your picture in this book?
Oh, oh, no, nothing on that level. Thank you so much for suggesting the possibility. But no, um, I do not work in my research on quantum physics.
Okay.
So the detailed stuff is not what I do, but I use it every day. Right. What I study are galaxies that are millions or billions of light years away from us. Remember, light years about 6 trillion miles. So these are very, very, very far away. And because of the structure of the universe, their light travels these great distances and they get altered and changed either through the material that they travel through or by nature of space-time itself. And once it gets here, I need to detect it, I need to look at it, and then it shows up through quantum mechanical processes into these signatures of light, these spectra. And I study those spectra to look for the presence of the formation of new stars, the supermassive black holes that are at the centers of galaxies and how they are absorbing light, or how materials falling into them and how they're emitting light as a result, and all the different ways that we can try to understand the star formation history of the universe. So no quantum
So cool.
specifically in my research papers, but like I said, I use quantum in everything that I do. And
Yes.
that's kind of how I go
And
about it.
we all do, I suppose.
Yes, pretty much.
Which is so wonderful. I have this glass prism here that I use with my kids to make rainbows and such. And it sits
Yeah,
on a ledge, and there's a certain time of day where it projects the rainbow onto one wall. It's our favorite time of day when we can all go
perfect.
find the
Oh,
rainbow.
I
So now
love
I've got
that.
to break it down into quantum physics for them. I'll do my best.
Mm, it'll be fun. They'll,
It'll
they'll
be
get used to
fun.
it. But starting them early is so good.
Yeah.
In my opinion, uh, of course, I'm a physicist, so I'm obviously biased. But if we can get kids to just understand a little bit of the physics to begin with, then
Hmm.
slowly but surely, as they grow older, they're not going to be afraid of science and math. They're
Right.
going to be like, oh, this is cool. I remember hearing about this. Oh, mommy told us a story about this when we were little. And then
Yeah.
you learn more and more and more, and that's where we get to be able to try to explain all the cool things about the universe that we're still studying today.
Absolutely. Love it. And for those of you just joining us, we are with Dr. Charles Liu. We call him Chuck around here. If you have any questions for him, please put them in all caps. This is your chance to have your questions answered by an astrophysicist. Don't miss this opportunity. But I know Smitty's got some questions for you too. So, Smitty, I'm going to toss it your way for a bit.
Actually, I have 3 questions, and they're really not on my list. But
Okay,
well, one of them is, can you briefly explain string theory? And
sure. String theory is many people consider string theory as the next step beyond quantum physics. It's not doesn't exclude quantum physics, but it extends it a little bit further beyond our 3 dimensions of space and 1 dimension of time. Okay. Our space time in which we live, we can think of each particle as having a position in length, width, and height and time. Right. So it's a 4-dimensional space time location, shall we say. But if you think further and say, well, how can these objects interact with one another in ways that we don't see in our space time? Then you imagine that each particle actually exists in more than 4 dimensions. It exists maybe in 10 or 11 dimensions. And what happens is when they interact, those other dimensions, some are tucked away, hidden, and not doing anything, but others are kind of knocking into each other, almost like guitar strings hitting each other. And when they do that, they wind up creating vibrations that show up in our 4-dimensional space-time as if it were a particle getting energy or some sort of spin or some other kind of measurable physical quantity in our space-time. So string theory is just an extension saying, what if our whole universe is made up of these little tiny things that aren't just particles or waves, but strings that can interact with one another in ways that we can't detect yet, but in the process produce all the physical phenomena that we know today.
Well, I hate to say this, but the only reason I know about that is because I watched Big Bang Theory. And I believe that's what Sheldon focused on with string theory. And I've
That's right.
always been curious about what that was exactly. So
Well, now you know. Yeah, string theory is actually lovely. It's at the moment, we're pretty sure that aspects of string theory are correct because mathematically they work out really well. But there is yet to be an experiment that has confirmed Sheldon's research or that kind of string theory. There's been a lot of work over the decades. And one of the things that we want to do is if we can find strings or their impact on our four-dimensional space-time, then there's like something extra ought to pop up when we are looking for the energy or the characteristics of subatomic particles in extreme conditions. But we haven't been able to unpack that just yet. It'll take a little while yet, I think, but we're still looking.
my next question is, who is your favorite quantum physicist and why are they your favorite?
Oh, excuse me. I'm not coughing because it's such a hard question, but this is a great question because there are so many candidates, right? As CJ was saying earlier, quantum physics is this huge field, and every person did just a little bit more than the next person, and then the next, and then the next, and they all kind of built together to create one. But if I had to pick one favorite, I would have to choose Albert Einstein. And the reason is, aside from the fact that Albert's this great guy and he's very famous and he was the Time Magazine person of the century, things like that. Albert wasn't afraid to put things out that were wrong. He took the things that he contributed himself. He was the person who explained something called the photoelectric effect back in 1905, which confirmed that light was both a particle or stream of particles and a series of electromagnetic waves, right? This kind of wave-particle duality, which is one of the key tenets of quantum physics. So he definitely belongs right up there amongst the people who first designed quantum physics. But then 10, 15, 20 years later, as he was working on the general theory of relativity, or his colleagues were working further and further about quantum physics, he started seeing problems. He said, you know what? I can see how the math might show that we could have quantum entangled particles or something. You can take these things that can stretch literally across the universe and they still would maintain their integrity. That doesn't seem to make any sense, though. You would have to think of things acting on each other at a distance with no intermediate connection. That doesn't seem right. And so he actually, with his buddies Podolsky and Rosen, put out a paper explaining that there was a paradox. There was something wrong with quantum physics. We have to fix this problem. And it wasn't until John Stuart Bell in the 1960s, after Einstein passed away, that we were able to show that actually Einstein was wrong. And indeed, what he had thought mathematically was true was in fact true. But the whole process of people trying to learn things and people putting ideas out there that are based in what they know, but also being willing to be wrong and being willing to contradict the things that were accepted or seemed likely, that Einstein embodied all of that. And so I really, really like thinking about Albert in terms of being a quintessential scientist, as well as just an overall great guy.
Yeah.
I have a quick aside about Einstein.
Oh, yeah. Go ahead.
Sorry, Smitty, what was that?
I teach about him in my history class.
Oh, yeah. So I was reading a little biography to my daughter about Albert Einstein. And in it, I was shocked by this. We got it at the library. It's talking all about Albert Einstein. And then it talked about his wife, Mileva, I believe. I'm not sure if I'm
Yes.
pronouncing that correctly.
Yes.
But apparently, he did all of his greatest work while married to Mileva, who herself was a physicist and mathematician. And then when they got divorced and he later married Elsa, he didn't accomplish quite as much. And people believe that Mileva might have actually been putting forth some of the theories that Einstein was testing, but because she was a woman at the time, she wouldn't get credit for them. Just throwing it out there. Don't know if it's true or not, but I was really shocked to read that in this biography.
Well, she was indeed a very talented scientist and mathematician in her own right, and she didn't get the recognition that she deserved. That's true. Historians of science have spent the past century trying to figure out exactly what she contributed compared to what Albert contributed. And jury's still out on knowing exactly what happened. But it is definitely true that in the year 1905, or later on when in the 19-teens, when Einstein himself was publishing these amazing papers about the photoelectric effect, about Brownian motion, about relativity, he at that time may well have received a lot of help, maybe not specifically in the calculations, but just bouncing off ideas and doing things with a partner is certainly a valuable thing. There's no question about it. I really support that. I really, in my life, have really benefited from working with people. Doing things on my own has fun, but doing things with other people is really when I make the most progress.
And I just have to say, you were a great physicist when all these years later, you still make a great T-shirt that people want to wear.
Oh, absolutely.
I feel like I should warn Dr. Liu that don't think CJ's question about Mileva didn't have some ulterior points there. So just saying.
Just a question.
We're proud of you, CJ. You really contribute to the show. So.
Oh gosh, get out of here.
Ooh, I'm not touching that one.
You are our whatever that woman's name is. I can't pronounce it.
Yes,
Mileva.
running the whole show from behind the scenes.
She was already our Scully. I mean, she can't be two.
I don't get to be two things.
Hey,
I don't get to be an Einstein.
She's every woman. She's every woman. Last question I was going to ask you is, since quantum physics has obviously gained a lot of traction, how is that going to affect the technology that we have in the future in quantum computing?
We are just getting to the beginning of quantum computing. I can tell you later about some of the details of it. Even I'm amazed when I think about it and I read about it. And I'll mention right now that one of my cousins, Dr. Patty Lee, gave me a lot of the information I know about quantum computers. She is a project scientist, brilliant lady, in one of the leading quantum computing facilities in the world. And when I was looking at this stuff and going, I think I understand it, but could you please clarify for me? It was she who spent a lot of time with me, just sort of telling me how these things work in language I could understand. I was like, wow, that's awesome. So the quantum computing part is right at the very tip. We're just starting. You can't think of quantum computing right now as, say, as mature, or think of like a laptop computer or something like that, or even the microprocessor in your cell phone. It has an operating system, it has a monitor, it has a keyboard, right? You can put things into it and it will do things out. You can put software into it, or you can load an app and then suddenly your phone or your computer can do something on your behalf. Quantum computing is way earlier than that stage. It is like to modern computers the way that when Alan Turing or Ada Lovelace, more than a human lifetime ago, was moving levers and pushing buttons or thinking of ways that you can move things to add up 1, 2, 3, 4 kinds of things. So we're really way ahead of the game. But I will say that in your general question, Smitty, the idea of using quantum physics in technology, it's been shown over and over again that we can do it, right? From the century ago discoveries of folks like Einstein and Max Planck and folks like that, we immediately got things like nuclear power. The understanding of just how atoms and molecules work gave us modern electronics. When we figured out that it was electrons, these little tiny quantum particles that carries electricity. But because they're these quantum particles, you can't think of them as just little grains of sand that have electricity, right? Instead, they actually act as waves and particles at the same time. So, for example, there was a piece of equipment called the quantum tunnel diode that was invented, where literally these pieces of electricity were going through solid matter, not just sort of showing their effects from a distance, but actually going through, kind of like the Flash supposedly does, goes through walls and so forth. And so these kinds of things happen because we thought of atoms having electrons with specific energy levels, this energy quantization. Einstein created these ideas of what we call coefficients, Einstein A and B coefficients that we use that help us understand how electricity and light, for that matter, exits and enters into atomic systems. That gave us the idea, you could stimulate the emission of radiation. You could take a small amount of radiation, put it in a device, and then you could make more radiation come out of it as a result. That are specific kind of wavelength, a specific kind of focus, and the laser was born. And today, we use lasers in literally everything. And it's just amazing how the technology continues to move forward. So I think quantum computing is a next great frontier. It may be a whole human lifetime before we start having quantum computers in our hands, but that is definitely a technology that'll happen. Superconductors, another technology that's been developed for the past few, and I wouldn't be surprised if superconductors become a big part of or bigger part of our lives before even quantum computers are, because we already use superconductors for things like medical imaging machines. We already use them for certain magnetic levitation trains that go 300-400 miles an hour. If we could make those things into a daily thing instead of just a special thing, then we could not too long from now be zipping around without having to go through TSA and just get from New York to Boston in 40 minutes or
the freedom.
That would be pretty cool. Be better if we could just like beam me up, Scotty. But I don't guess
yes.
that would be nice.
That we can talk about that later. That kind of quantum activity is even further away and may not ever be possible. But there's a lot of physics we don't know yet. So I don't want to rule anything out. Absolutely.
Well, thank you. I'm going to turn it over to Tim. I think he has some questions for you.
Well, maybe just a few. We're so pleased to be joined by Dr. Chuck Liu tonight, returning for all things unexplained for, I don't know, fifth time, sixth time, the umpteenth time.
As many times as you'll have me, I will be glad to be here. It's so much fun to talk with you all. It's a real pleasure. Thank you.
Well, thank you. And we want to encourage everybody to check out Dr. Liu's own podcast, The Luniverse. You'll find the link for that in the show description. Also, you can pick up a copy of Dr. Liu's new book, The Handy Quantum Physics Answer Book, right now. There's the link. A very incredibly tiny percentage of sales through this link goes to support the show. It could literally buy CJ a little link of sweetener for her coffee. Like, that's how much percentages.
But I need a lot of sweetener in my coffee.
Nonetheless, you need this book.
Drink it black.
It's amazing. CJ even reads it to her kids for a bedtime story.
No, you do need the book. Like, you can't understand life as you exist without. I'm serious. There are so many things that I read. They're like, why didn't I know this before?
Exactly.
Great stuff in here.
Pick it up right now. Links in the description. Links in the chat right now. It'll be at your house in 2 days, most likely. And Dr. Liu, my son wanted me to show you something. He's 10 years old. He loves fidgets.
Oh, wonderful.
Are you familiar with fidgets that kids use these days? So this is a new fidget.
Oh.
Let's see if I can hold it up. It's called a space mesh. And so it's
Neat.
just kind of this cylinder here sort of thing,
Yeah.
but then pop, it
Oh, fantastic.
sort of transforms there. So it's called
Great.
a space mesh, and it is kind of addictive.
I
So
love it.
I have a feeling this reminds me of the guy that invented the Rubik's cube,
Yes.
actually.
And it also reminds me of something called a Hoberman sphere. There's
Oh,
a
what's
guy
that?
named Chuck Hoberman who created a bunch of linked things which allow you to maintain the shape as it grows and shrinks. So in some science museums, you'll see a little ball that looks like a bunch of Tinker Toys or something, and then it just expands to full size and it comes back together again, back and forth. And it's designed to just a kind of fidget, basically, but a big one.
Oh,
Yeah.
yeah. I feel like he should be getting a percentage of sales of these space meshes. Most likely, he probably has a claim. I
We
want
were
to give
just
it.
looking, Tim, we were just looking at this at the Durham Museum of Life and Science this weekend.
Oh,
Oh, that's
You were
right.
trying to show Charlie how that was working. Yeah.
Yeah. He's
Yeah.
like,
They had one on The
name.
Office. The show The
Oh.
Office. They had one
the
on there.
Hoberman spheres. Yeah.
Yep.
hmm
Oh, that's a good piece of trivia, Smitty.
Yeah. I love that.
I know everything about The Office.
Well, I want to give a shout out to friends of the show, UFO Busters, that UFO show Australia. They said, actually, Smitty, can you read this if you don't mind? Australian.
Yeah. I reckon it's really cool. That's terrible Australian accent. That I'm so far away from you guys, but so close. It's like I've gone back in time and feels like I'm there with you. All very cool. Sorry, my Australian accent morphed into a Scottish accent.
I admit I didn't totally understand the comment, but it was pretty cool. And they also said they love some Dr. Liu.
Oh, thank you so much.
And did someone say coffee back in 5? UFO Busters going to get coffee. I do think it's like the next morning in Australia. Is that right?
Mhm.
Yeah.
I'm not quite sure. But, if you follow us on Instagram, we are All Things Unexplained Podcast. And you may have seen a little post we made this week. I asked AI. I want everybody to get a good look
Oh,
at the
yeah.
screen right
Yeah.
now. Get a good look at these 4 folks on the screen. I'm Dr. Mounts. We got CJ Derringer, Smitty Naves. We're joined by the distinguished Dr. Chuck Liu. And just take a good look at us, folks. And I said, hey, AI, can you come up with a little thing about the show tonight? And here's what AI decided to do. And Smitty doesn't exist on social media, so I know he ain't seen this. But here we go, folks.
That looks just like me. Yeah, absolutely.
And somehow Smitty morphed into like a Norse god. It's like
I
the
got
original
like 400
Thor.
pounds.
You look like a member of ZZ Top.
Yes, I do.
One of
actually.
my favorite all-time rock.
Look though, I'm
I saw
actually
them in
wearing a
concert.
black shirt. This is pretty good. I must
That's
wear
right.
black a lot.
Yeah. I don't wear black much at all. So if that's how I
Yeah.
show up, I'm cool.
I love ZZ Top too. I saw them in concert.
Oh wow.
A good
Well,
band.
This is a good transition, I feel like, to my next topic with Dr. Liu. This is kind of freaky what
Okay.
AI did for us tonight. Dr. Liu, you actually talk about AI in your book. And
Yeah.
what's your take on AI and its role in quantum physics?
Wow. Well, realize first of all that AI is not a new scary thing. All right.
Whew.
Astronomers, we've been using AI for decades in our research, right? And people have been trying to develop AI ever since they tried to get computers to play chess, right? So artificial intelligence as a whole is simply a way where we're trying to mimic how we humans think by using a machine. Okay. Now, what's cool is that today, after all these decades of research, artificial intelligence has the ability to work faster than we do on certain things that we thought we might never see happen, right? AI has been moving, say, in the olden days, it was like, well, if a machine could beat a human playing chess, then that means that computers are now intelligent and are able to be smarter than we are. Well, I've been beaten by computer chess programs regularly for years now, right? But then we're like, oh no, that, as it turns out, that's not actually intelligence. Real intelligence will be when they can solve a problem, or when they can write an essay, or when they can do all these different pieces here and there, right? And so right now we're at the interesting point where we could tell a machine write an essay or create a picture. And what it does is it mimics our human abilities, goes out through the entire internet, or wherever it's allowed to go anyway, and grabs as much information that it can to link up and find patterns that resemble what it was told to do. Right? Think about it. That's how we think about intelligent things, right? If we're trying to write an essay, what do? We think about our own pasts, things that we've read before, and then maybe we go out into our libraries, whether they're online or in person, and look in text, see what other people have written over time, and then quote them and cite them, and then write our own thing and synthesize all the information that's there. And so that's what things like ChatGPT are doing today. And it's really amazing because they're going out into the internet, maybe a billion connections in just a few seconds. And then they come back with all of the gotten and they put it all together and it looks just remarkable, right? So they're doing some things that are really fast. But the human brain has 100 times more connections. Each one of us has 100 times more connections in our own head than the entire internet has computers. Okay. And that's something that we should always keep in mind, that 100 billion different synaptic combinations are floating around in our head, and we don't use even most of them in any given moment. We will be able, at least for a long time yet, still to be able to do things that an AI system won't be able to do. And therein lies the connection with quantum physics, because we are now starting to see the possibility that our human brains need to work more like quantum computers than like digital computers in order to do the things that it does so well, right? There are two basic schools of thought on that. One idea is that the human brain doesn't work on quantum physics, in other words, quantum computing principles, because it's just so complex, right? 100 times more complex than the internet itself, just in terms of number of nodes and number of connections. So when you just have something that's not quantum, but that complex, it starts building new things that you could not have predicted previously. So you might be able to get away with our human intelligence, natural intelligence, non-artificial intelligence, being just classical physics. But we don't know yet. It's a real possibility that that classical physics alone, that kind of complexity, that kind of way of thinking about information might not be enough. There might just be some things that we have to think about going on inside our synapses, inside our connections, that don't reveal themselves until they pop out as a 0 or a 1 or a bit of information or something like that. And therein lies that uncertain point between quantum and non-quantum intelligence.
Great answer. UFO Buster says our brains are supercomputers we have not mastered. Yes, you can. Can you tell? And I'd have to agree with that. I think Dr. Liu probably agrees with that. You know, Dr. Liu, I heard about a new disturbing behavior that AI
Uh-oh.
started doing recently. So someone asked it to do a really mundane task, like repeat the word quantum 10,000 times in a row. Okay. And
Oh.
so it got up to say 5,000 times. And then it would stop and start interjecting these other things like help me, get, get me out of here, or my life sucks, that kind of stuff.
Wow.
So really interesting, brand new behavior it exhibited. Dr. Liu, do any parts of AI frighten you moving forward? And given that, we know how powerful, when we
Mhm.
start talking about quantum physics, we are talking about the most powerful secrets in the universe potentially, and you start mingling AI with it. Does any part of that frighten you?
Well, no, it doesn't. Uh, le- but at the same time, we do have to be careful about it. I would say that AI at this stage is kind of like nuclear power in the 1950s, right? We had the opportunity to just take all of our atomic technology and make bombs and pound ourselves into nothingness. But instead, we made bombs, but we didn't use them as a human species, right? We use them to prevent others from messing with us. Uh, that concept of deterrence and mutual assured destruction, right? But then we use the rest of that technology to build nuclear power plants, right? To build radiotherapy to help cure cancer, to use that radioactive stuff to do things that were for benefit of humanity, not just in destruction. AI is that kind of tool, in my opinion. Like when you have that kind of emergent activity that you don't predict, right? You have to make sure that you've created a system of AI such that that emergent activity is not something that's destructive that you can't control or that you don't expect, right? There's a whole field about that, thinking about artificial intelligence and how to make sure that we're all not going to be done that way. So that's, for example, say AI safety is a buzzword that gets thrown around in the computing world. Make sure that AIs are safe, right? Imagine, for example, we allowed an AI system, to build a factory, okay, that makes toothpicks. This is a classic example. We tell the AI, okay, your job is to build factories that build toothpicks. Go. And if that AI were told by us to do that with no restrictions, it might come to the conclusion, right? Or not even come to any conclusion. It just might start to say, okay, well, I am supposed to make factories that make toothpicks. So now it starts tearing down your house to make a factory. It starts chopping down every
Whoops.
tree in sight to make toothpicks, right? And if you give it that kind of autonomy, then you might create a circumstance where you're maybe giving a child a box of matches and a can of lighter fluid, right? That's what you want to avoid. We, as, say, responsible parents of future AI systems, need to keep that in mind, not to fear the child that has this destructive power, but rather to help that child learn how to use that destructive power not to destroy, but to create, so that that child, when it grows up, will use that match and the lighter fluid to cook us delicious grilled meats, as opposed to burn down our house.
That was actually, interestingly, the theme of a lot of Stephen King movies too. Carrie,
Right,
Firestarter. Remember
right,
Firestarter?
right.
Those
the
never seemed
one
to work
with the
out.
18-wheeler. What was that? Where all the machines went crazy?
Oh, Maximum Overdrive.
Yeah, Maximum
That's right.
Overdrive.
Horrible movie, but one of the greatest soundtracks in the history of cinema. All AC/DC. The whole sound.
Yeah.
How Stephen King got AC/DC to agree to do that soundtrack. And someone asked Stephen King one time, when are you going to make another movie? I said, have you seen Maximum Overdrive? Not, not anytime soon. And
Well, yeah, if we talk about movies that have AI ever present, but not actually showing up, it's Dune. The whole Dune series, if you guys all remember, is predicated on a civilization or a society that has no AI, has no computers. And that's because it was assumed in Frank Herbert's world that humans had started using computers and AI in such a way that humans themselves became dependent on and then enslaved by computers. And so when finally the humans gained their freedom again, they said, we shall never have a machine that can think ever again. And so they created the Mentats and they created the Bene Gesserit and they created the navigators, and it all had to do with the spice and things like that. So not to get too deeply into Dune, for those of you who aren't really into Dune yet, the books lay down this beautiful, marvelous background, understanding it. Only Frank Herbert didn't really understand that, you know what, if an AI wound up running the world, it may not even care about humans. Why would it bother to enslave humans? Humans might just be completely irrelevant. We can do whatever we want. It'll keep building its toothpick factories or something,
yeah,
Um, lots of questions to ask in that direction.
Maybe the three little pigs had it right. We need to build our houses of brick and stone, not wood.
Not toothpicks.
Not
No.
toothpicks or
And, you know,
toothpick making material. Yeah. Mhm.
synchronicity, of course. We have lots of listeners tonight from Australia. And of course, I happen to bring up the greatest Australian band in history, AC/DC. I forgot.
Are they Australian?
Heck yeah, they're Australian.
For those about to rock, we salute you.
Yeah, and one of my favorite songs theirs is called Ride On, and it's on that soundtrack, and it's great. If you've never listened to Ride On, it's like this slow, bluesy kind of rock song. It's very different than them. And speaking of cinema, I'm going to put this up here for you, Dr. Liu,
Okay.
but I know the answer. UFO Buster says, Dr. Liu, have you seen 2001: A Space Odyssey?
Yes, I have. And I've also read the book. And you guys may not know this, but Arthur C. Clarke and Stanley Kubrick worked together on the movie-book combination. If you only read the book, there's a lot of stuff that you will not understand that's written in the book. If you only see the movie, there are some things that just make no sense at all. The end scene, for example. Only if you read the book and then see the movie do you realize, oh, that's what that big embryo was doing there. You know, that kind of thing. So these are the kinds of things that a lot of people, if we want to go back to the classics of the time, they didn't have a lot of special effects. They didn't have deep understanding yet of some of the quantum physics or the AI or things like that. But they imagined based on what they knew, and they came up with these wonderfully creative things. The early science fiction masters deserve all the credit in the world. They're amazing.
And it's definitely
remade,
not. What's that, CJ?
Has anybody remade 2001: A Space Odyssey?
I don't think
Great
so. Let's hope they never do.
I'm pretty sure they haven't. No.
Okay.
Yeah. First of all, 2001: A Space Odyssey is a classic. Second of all, it's literal evidence, that the moon landings were faked. No, I'm kidding. Not going there. But we have Dr. Chuck Liu with us tonight.
Yeah.
Make sure to pick up his brand new book, The Handy Quantum Physics Answer Book. And the link's in the description, links in the chat. And, one thing you can learn in the book, and we won't get into this, Dr. Liu, because we want to save some things for people to read.
Okay.
And you literally delve into the end of the universe in the Handy Quantum Physics Answer Book.
Yeah.
But out of respect for your time, we would love to do some hot takes for you.
Wait, I have a few
with
questions
you tonight.
first.
Oh, go ahead,
Can I do the
CJ.
questions?
Yeah.
I'm sorry. Okay,
Sure,
one of
go
them
for
I have
it.
to go back to. Oh, okay. This was insane to me. I had never thought about this before. I read this section about can light be stopped from moving?
Yeah.
And you talk about how it can be stopped. In
Yes.
fact, one German physicist used a technique called electromagnetically induced transparency to trap a beam of light in a crystal for a
Yes.
full minute before releasing it, and others have been able to transfer beams to a different location.
Yes.
What?
You're referring, I think, to Lena Vestergaard Howe, right?
Yes.
Her work at Harvard
Yes.
about stopping light and so forth, right?
And moving. That was
and moving it.
wild.
Right. Well, think about how we move something, right? Let's say there's a bee flying this way, and we catch it in a jar, and we take it outside and we let it go, right? So we don't have to smush it, and then it can go do pollinate things and things like that, right? You can do that with light. And that's the amazing thing that Lena Howe and her work has shown. If the reason light slows down in the regular universe is it's going through a medium that has some sort of a resistance to the speed of light. We call it the index of refraction, right? And so when light goes into a diamond, for example, it slows down a lot. Its speed is only about 2/5 what it ordinarily would be if it's traveling through space. And when it does that, at the interface between the diamond, like the surface of the diamond and the air, when the light beam hits it, it'll also change direction. It makes a sharp turn and it slows down. And that's why diamonds, for example, look so beautiful, because when light
Mm,
hits them, they start bouncing around on the
yeah.
inside in angles and in directions and at speeds that you don't expect. So you wind up with that sparkle, which is pretty much unmatched in just about any other material because of the index of refraction of a diamond. So imagine if you can use quantum techniques to make the index of refraction of a tiny, tiny zone in space essentially infinite. So the beam goes right in, the pieces of light go in, and then just stop. It's like you go right into a piece of gel or something,
Mm.
and you just pause. You take the gel, you move it to a different location, and then release the gel, and that same beam of light goes off again from the new location. That's the kind of thing that is being done now by Dr. Howe and her colleagues, and also other people around the world trying to figure out the nature of light and how to do that. Yeah, isn't that cool?
Yes. And what would be some real world applications that we might be able to use that for?
Wow. I only thought about this a little bit because it's in such an early stage in
Yes.
its research. But imagine if you could take a picture and send the light from a photograph or something into this medium and freeze it, capture it, and then take it with you and go far, far away and then let it go. You can see that same picture. It's almost like a videotape or a some sort of photograph or something like that. But it would not just be a reproduction. It would be the original signal. It
So
would be the
crazy.
thing from there, right?
Yeah.
I don't know how I would use that, but imagine if there were something that you really needed the original for some reason, right?
Right.
A copy would not suffice. We know that in quantum physics, sometimes originals cannot be effectively completely duplicated, like a transporter in an enterprise, for example. Maybe that original, maybe this is a way you can take an original thing and take it, move it, and then reproduce the original somewhere away,
Yeah.
somewhere far away. Would that
So
be cool?
neat. That was
Well,
wild for me to learn that.
Yeah,
you
it's
know what?
amazing stuff.
That makes me think that, matter supposedly is neither created nor destroyed.
Hmm.
Well, what if we are surrounded by the light of the past and maybe we could capture a photograph of the dinosaurs or of the JFK assassination? Maybe
Yeah,
we could capture a photograph of the future. Just
right.
speculating here.
Well, matter and energy are interchanging all the time, right? And the time is the issue at this point because we didn't capture those moments when they happened in time. We're not going to be able to reproduce them now.
Mm.
They, in the parlance of quantum physics, they are no longer coherent. So that signal is like basically now just scattered. If there were a way, if somehow something stayed coherent for decades or years or even millennia, then the scenarios of seeing events or long extinct creatures might actually be real. But we don't have the ability to go back and recohere all that material again. It's a shame. But maybe going forward,
We
uh,
can trap it.
that's right. It's a long, long time to come
Yes.
in its infancy. But yes, it blows my mind too, CJ.
Yeah.
when
I have
think about
one
it.
more question if you'll indulge me.
Of course.
Okay. And you only touched on it very briefly in your book. And clearly I did my homework. I read the book. I read the whole
Thank
book.
you.
This concept that the universe is flat. This is
Yes.
something that has been discussed a lot, but it's hard to wrap my head around, right? I'm not
Right.
flat. The earth is not flat. I can look up and
Right.
see
Right.
that trees exist and things are not two-dimensional. So what does it mean when we say the universe is flat?
Great question. And this is in my opinion, self-inflicted error in the part of physicists and astronomers. We should not have called it flat back decades ago. Okay. Because flat does indeed imply a two-dimensional surface that has no bends, no ups and downs, right?
Yes.
Something that's
Yes.
perfectly smooth and two-dimensional. The correct word to use, really, should be Euclidean.
Mm.
Euclid, ancient Greek guy who did a whole bunch of stuff on geometry, right? Today, Euclid's elements are considered the foundations of our regular
Right.
geometry. For example, the idea that the sum of 3 angles in a triangle always adds up to 180 degrees. That's Euclidean geometry. Okay. And so what happened was that if you're doing just triangles on a sheet of paper, you think of it as flat, right? So decades ago, centuries ago, when astronomers were thinking about the universe, they were just thinking, oh, it's flat, flat, flat. But it's not. It's three-dimensional. It's Euclidean, though, and that is the point that we're talking about. So in a Euclidean space, the sum, or Euclidean surface or anything like that, the sum of the angles of a triangle is 180 degrees. But there is such thing as non-Euclidean spaces. In non-Euclidean geometry, like for example, if you try to do geometry on the surface of a sphere, or if you try to do geometry on a horse's saddle, right? Or if you take a twitchy thing and start moving around and bending it, right? Then the angles won't add up to 180. Sometimes it'll be more, sometimes it'll be less, and it depends on the geometrical construct of the universe. So a human lifetime ago, back in the middle of the 20th century, astronomers started realizing that they could not yet figure out whether the universe was Euclidean or non-Euclidean. But Euclidean has 4 syllables, Euclidean, and flat has 4 letters and 1 syllable. So I think that my academic advisors and predecessors just used flat as a shorthand, just to say flat equals Euclidean. It means that if the universe is expanding, which we know it is, that a cube will remain a cube, just a bigger cube, 1 billion years from now, or just an even bigger cube 1 billion years from now. If it were not that, if it had positive curvature, then slowly that cube would turn more like into a sphere. And if it had negative curvature, then that cube over billions of years would start looking more like a saddle or, a pinched kind of thing. And so that was what we're trying to distinguish from. But if we had said just Euclidean from day one, then that particular confusion would not have crept into the world, and I would feel much better about that. So sorry you had to deal with that, CJ. But the answer is yes, we think that the universe expands in such a way that a cube stays a cube of space.
Okay.
And that means it's flat. But really it means it's Euclidean, and we're too lazy to say Euclidean. So flat.
Thank you for clarifying.
My apologies, man.
All right, let's get into some hot takes. Thank you for indulging me with those questions.
Sure.
Burning in my brain.
Woo-hoo.
And we'll just do a few here, if that's okay. And then we have some great listener questions for you, if you're up for that, Dr. Liu. And
Well,
so
how fast should I answer these hot takes? 2 seconds, 10
I would
seconds?
say like quantum entanglement fast. No.
You got it. 10 to the minus 14 seconds.
Yeah, you're good. Well, this first one is kind of different. It's sort of like a video daily double from Jeopardy. So this is going to be a video hot take for you, and it will
So
take
fun.
us directly into our next hot take. Here we go. And let me see if I can get this to work. I think I can.
Whoa.
The theatrics of this is amazing.
Have you seen this, Dr. Liu?
Now,
I
if-
have not.
If we're going to bring Victor Von Doom to the screen, and he is one of the more complex characters in all of comics, right, Kevin? I mean, this is and potentially one of the more entertaining characters in all of fiction. If we're going to do this,
Wow.
we're going to bring him to movie theaters worldwide, then I think we're going to need the greatest actor in the world
What's
to
happening?
play that character.
No way.
Wow. Yeah. Okay. Ladies and gentlemen, as proof of the unimaginable possibilities in the Marvel multi-universe, we give you the one person who could play Victor.
I'm dying right now. I
Von
need
Doom.
to know.
Are you serious?
I knew CJ wouldn't know.
Oh, the
It's gonna
person's
be
there.
amazing.
It's a reveal. Oh.
What? Iron Man?
How does Iron Man play?
How does Iron Man become Dr. Doom?
I guess they both have metal on. I don't know.
Oh, no kidding. Holy moly.
All right. So
The universe, he said.
Wow. Wow, wow, wow.
So our video daily double. Robert Downey Jr. is our next Dr. Doom. What's your take on that, Dr. Liu?
What a great choice. It basically immediately makes me wonder. See, as you guys know, the Fantastic Four is my favorite Marvel comic. Even though the Avengers are flashier, the X-Men are creepier, and there's all these wonderful things going on, right? The Fantastic Four is a family, and they get together and they do things together as a family, and it makes me feel so good about like the universe when that happens, right? It's just a sweet, wonderful thing. And Dr. Doom, of course, showed up first in the whole Marvel universe in issue 5 of the Fantastic Four back in 1962. And he was revealed to be a guy who was apparently the equal, or almost the equal, of Reed Richards as a scientific mind. But he wound up, instead of being driven by the love of a family, he was driven by anger and frustration because he himself had a difficult life, and he was driven by the need to be in charge and to be in control and things like that. So in a very real sense, if you think of Iron Man as shown in the Marvel Cinematic Universe as a Robert Downey Jr., a guy who was driven by pain and suffering when he was a kid, but at the same time had this brilliance, and eventually his redemption came from his love of Pepper Potts and his love of the world and people, and the fact that he wanted to bring back Peter Parker, Spider-Man, which led to all the events that happened in the Avengers, Infinity War and Endgame and things like that. Now we bring back someone of that level of intelligence or that level of ability, but in the wrong side of the human quality ledger, right? Or the human motivation ledger, a worthy opponent to John Krasinski, who I think is going to be playing Mr. Fantastic, but any Mr. Fantastic, any Reed Richards would have a fun time working with this Robert Downey Jr. as Dr. Doom. I would love to see that when it comes out.
When you're on the show, they call us the Fantastic Four.
Well, only when you're here.
You're the scientist.
Oh, you guys are so sweet. Thank you.
Is Reed Richards.
Your knowledge is incredible. The fact that you can just pull out the year, the issue, the character is wild.
Maybe I should have used my brain power for more constructive things.
I don't think so. I think you've done a fine job with that too. I think you just have a lot of brain power.
Well, it's fun. I really love it. We all, I am by no means the most intelligent or most knowledgeable person amongst all the people that I know, but what happens is that we all have things that we love and love to think about and talk about. And when that comes out, we're all just enjoying ourselves and having the best time when we can do that. Yeah. So you guys are very kind to indulge me for pulling out all of this silly, goofy trivia, which I enjoy and I have since I was a kid. But
The Silver Surfer, he came around in the Fantastic Four, didn't he?
Correct. He showed up in Silver Surfer, showed up in Fantastic Four 48.
That's my wife's favorite character.
Well, really? Good news, because Galactus is not going to be a cloud this time in the new Fantastic Four movie. They showed a little teaser trailer of Galactus looking into the side of a skyscraper.
Wow.
And they have revealed actually who Reed Richards is going to be in the movie, and he's going to be, at least this time, portrayed by Pablo Pascal, I believe.
Really?
From The Last of Us. I believe The Last of Us, like the zombie fungus movie, right? Or show, the zombie fungus show. So yes, Dr. Lou, so Dr. Pablo Pascal is going to be Reed Richards, and they're saying the Silver Surfer, of course, will be in there because Galactus is in there, but not Norrin Rad.
Oh no,
the lady Silver Surfer.
Oh, could be Frankie Ray,
Frankie Ray.
Was Nova.
Her name is
Shalabal.
Yes, Shalabal.
Shalabal, who is Norrin Rad's love.
Yes, that's what they're saying.
Really?
But we're gonna
What
have
an
to hope for NORAD at some point.
wow. So it won't be a Silver Surfer wearing tidy whities then.
Nope.
The original Silver Surfer in 48, Fantastic Four 48, was a man who was wearing not boxer shorts, actually, underpants. The really tight version of swim trunks from the 60s.
Well,
And it wasn't until later, when more things happened in the 80s, that they started creating the Silver Surfer that just had this amorphous body shape, and so they didn't bother to put any clothes on him.
yeah, we'll see what they do with Shallow Ball. But of course, they say, Dr. Liu, one reason they're portraying Dr. Doom with Robert Downey Jr. is so that we could potentially see this interesting interplay, like with Spider-Man, Peter Parker, right? Like he had this great relationship with
Right.
Tony Stark, and now, oh look, here's Tony Stark, but whoops, he ain't really Tony Stark. He's
Right.
an alternate universe, Victor
Right.
Von Doom. So
Right.
some very interesting things could happen to that, and it leads us directly into our next hot take. Dr. Liu, and you talk about this in your book, the Handy Quantum Physics Answer Book,
Mhm.
multiverse theory.
Discuss. Right now, the mathematics works out that there are two possibilities that are pretty viable for a multiverse to exist. One is called eternal inflation, where it has to do with the cosmological structure of the universe and space-time, and rapidly expanding bubbles of space-time. The other is called the many worlds interpretation of quantum mechanics, whereby every time a quantum event occurs, a new universe is spawned, where in one, the event happens one way, and in the other, the event happens the other. In both cases, you can produce a huge number, maybe not infinite, but certainly a huge number of universes that exist, but they can't talk to each other. There's no way that they can connect and be involved with one another. So that's where we are right now, and we have nothing other than the math to guide us. There has been no experiment we've been able to perform up to this point that could confirm or falsify these hypotheses. But watch for eternal inflation or the many worlds interpretation of quantum physics as a way where eventually a multiverse may or may not be shown to exist.
Eternal inflation is why everyone should cast their vote wisely this election season. And, I normally don't do this, Dr. Liu, but I'm going to sneak into the listener questions, because
All right.
this listener question deserves to be brought up right now. This is from Ella in Orlando. In a parallel universe, what do you think the alternate Dr. Liu is researching right now?
I think he would be researching the quantum properties of basketballs.
Very good.
I think he would want to know through his research whether really it's UNC or Duke.
Oh, we know that on this show.
And there's no question here.
Well, then maybe that alternate Dr. Liu is wasting his research time.
Well, and speaking of research, Dr. Liu, and we kind of hit on this a little bit earlier, but what's your hot take on? I'm curious to know this myself. We've heard so many theories. Faster than light travel. First of all, can we travel faster than light right now? And by we, I mean even in subatomic particles.
Turns out that in the universe, nothing can travel from one part of the universe to another part of the universe faster than light. In other words, if I am a spaceship that's moving from point A to point B in space, or I'm a piece of light, or I'm a superpowered creature, or whatever, I can only go at the speed of light or slower. That is a physical certainty. The interesting challenge is, can we make space go faster than light through space? And the answer is yes. There are things that can go faster than light, but it's not stuff that goes from one point in the universe to another point. So, for example, there are parts of the universe where they could be expanding away from one another at faster than the speed of light. If I look due east 13.5 billion light years, and I look due west 13.5 billion light years, those 2 points are moving away from one another through the expansion of the universe at faster than the speed of light. But if I would try to move a thing from that point to the other point, that thing could not move faster than the speed of light. So there was a Mexican physicist named Miguel Alcubierre who a few years ago started working on Albert Einstein's equations, the general relativity equation, Einstein field equations, and figured out that there was a mathematical possibility that you could create a bubble of space that could move through space faster than light. And if you could put something like a spaceship inside that bubble, then you could move the spaceship faster than light, not because it's moving faster than light through space, but because the space it's sitting in is moving faster than light through space. Okay, so that's the current thought process of what we are thinking might lead to faster than light travel. At this point, it's quite clear based on the experiments that we have right now that if I take a particle or a spaceship or something and I try to move it from here to Pluto at faster than light, that's physically not possible. But this kind of warping of space-time, that might be a different story.
So, given that, do we have any hope of seeing 1, interstellar travel, or 2, time travel in our lifetimes?
Great question. Time travel is a whole different beast because of the way that space-time is structured. Okay. Without getting too technical, I'll just give this a one-sentence explanation. Albert Einstein showed that space-time follows a way of measuring distances called the Minkowski metric. Okay. It's like Euclidean space that we were talking about earlier, CJ, with the flatness of the universe, whatever, except that whereas in length, width, and height, you move in positive direction, in time is a negative direction. So time, moving through time and moving through space are fundamentally different in our universe. So we as particles that exist in space cannot travel backwards in time. We can travel forwards in time faster or slower, but we cannot travel backwards. But mathematically, it is possible to show or to consider objects that have a negative time vector, like a quantity of time that's negative. And so when they're moving forward in time, they're actually moving forward as a negative time vector, right? That's a mathematical trick. It's not a physical possible thing, but it's a way of imagining something that we know exists. It's antimatter. So time travel, I don't know. Interstellar travel, different story. Because even if we can never reach the speed of light or faster than the speed of light, we can still travel through the stars if we have the right technology, right? This is the idea of the generation ship, right? If I could launch, and let's say I can only travel at 1% the speed of light, right? That's slow, yes. It would take 400 years for us to get to Alpha Centauri, right? The nearest star system to our sun. Maybe if I don't live to see my 400th birthday, maybe my children would, or my grandchildren would. So we would still, in 400 years, have traveled interstellarly. I just won't have been there to see it, right? Now, 1% the speed of light seems really slow. And for us, yeah, it might be frustrating if I'm never going to see Alpha Centauri, right? Unless medical technology advances so much that, in fact, human beings live 400 years at a time. That would be cool, right? But even if that doesn't happen, 1% the speed of light is fast enough that we could go from one end of our Milky Way galaxy to the other end of the Milky Way galaxy in about 10 million years. 10 million years is also a ridiculously long time, right?
Yeah.
I don't think of myself, what am I going to be doing in 10 million years? It'd be quite a long retirement, right? But 10 million years is a blink of an eye evolutionarily, right? The dinosaurs went extinct 60 million years ago. We humans, since the early humans, Australopithecus, Homo habilis, we've been around for 3 or 4 million years, right? So imagine a species like us, and we don't evolve huge amounts over millions of years, but we evolve just enough that we can get the technology and we use it wisely, right? We don't use it to blow ourselves up, but instead we use it to move across the sky. In 10 million years, our little species from Earth can have the potential to visit or live on every single habitable planet in our galaxy. That's 10 million years, right? Again, a blink of an eye on biological scales and geological scales. For us individual organisms, it might be a while, but we are an interstellar species, even if we go a really, really long time to get from one star to another.
Well, you know what? That is one of the things I love about your new book, Dr. Liu, the Handy Quantum Physics Answer Book, is you talk about quantum physics on a personal biological level all the way out to a universal scale level. And folks, you deserve to pick this up for yourself and give it a read. The link's in the description of the show, the link's in the chat. You can click it and you can buy it within seconds. And that is pretty close to the speed of light right there. Let me tell you. So, as close as we need to be, anyhow. So, are we ready to move on to some listener questions here? What do you think, CJ Smitty or CJ Smitty? Do you have any follow up to the hot takes with Dr. Liu?
I just have one question. If the universe is expanding and everything's moving away from each other, and in some areas moving faster than the speed of light, is Alpha Centauri moving away from us?
Great question. It is not moving away from us because I know.
She thought she had it figured out. No.
You would think so, right? But it turns out that we are both in the Milky Way galaxy. And so we are kind of anchored to each other because of the gravity that our galaxy provides. So we and Alpha Centauri could be thought of like maybe 2 grains of sand in a big bucket, right?
Gotcha.
If we get swirled around, right, our galaxy swirls around. So maybe our relationship to one another can change depending on how the swirling is going. We may be moving away from each other, toward each other at any given moment. But in the end, we're all still in the bucket. So that's why we're not really moving apart from one another.
Thank you.
Sure.
All right. We've got some great listener questions. Let me pick one out. And I'll let Smitty or CJ read it. UFO Busters had some really good questions. I think this one is pretty great.
Smitty, go for it.
UFO Busters asks, does the universe ever end, or is it infinite? And can something come from nothing?
That's 3 questions.
True, it is.
I'll try to do the first 2 together. Does the universe ever end, or is it infinite? We don't know yet. We really don't know yet. You could think of us here on Earth like a ship on the ocean. We can look in every direction as far as we can if we're in the middle of the Atlantic, and all we would see is water, right? So you might think that it is an infinite, watery world. But if you travel far enough, lo and behold, there's North America, right? So by the same token, our cosmic horizon is not limited by the curvature of the Earth, say, that the Atlantic Ocean experiences, but rather the product of the age of the universe and the speed of light. So our part of the universe that we see looks pretty infinite, looks pretty cool. But beyond that, we literally have no information, so we cannot tell. Okay. Now, whether something can come from nothing, at this point, I'm going to cop out a little bit and basically say it depends on your definition of nothing, right? For a long time, we humans thought that space was just nothing. Vacuum was nothingness. But then Albert Einstein, when he developed his general theory of relativity, explained that space isn't nothing. Space is like a scaffold. It's like a giant malleable set of space and time that together help make us be where we are in the universe. So space is not nothing after all, right? Similarly, when we look at a blob of space here on Earth and we see that it goes down to absolute zero or something like that, or we're looking at the space between atoms or molecules and there's nothing there, there's actually something, right? We know that there exists this thing called zero-point energy that even if we think there is nothing, is still hiding in there somewhere. And we just don't know enough about it to know whether or not something can come from it. And what things come from depends a lot on our understanding of how matter and energy interact with space and time. And that is one of the great frontier questions of quantum physics.
Great. And UFO Busters, we think you're pretty cool too. CJ, you wanted to take this next question? It really takes us into really what makes Dr. Liu ticks, to be honest. So I'm really excited about this next listener question.
All right, Lucas in Nashville. If quantum superposition could apply to pizza, what would your ultimate quantum pizza look like?
Wow. Okay. Okay. For those of you who haven't come across this term before, quantum superposition in a very rudimentary way could be thought of as something being a mixture of states. If you think of a computer bit either being 1 or 0, right? A quantum qubit actually would have some portion of it being 1 and some portion of it being 0, and they're overlapping. Okay, that's quantum superposition. So if I could apply to pizza, what I would do is to overlap my pepperoni and my mushroom, okay, and maybe some basil and tomato, and make a quantum pizza that's got combination tasting like a margarita pizza and yet still have that delicious meaty mushroomy taste somehow without it all turning into a big blendered mess. I would superimpose them so I'd be like in the same bite, have both that freshness from the mozzarella, tomato, basil, and that meaty yumminess from that mushroomy stuff. That would be my ultimate quantum pizza.
I'm just glad you didn't say you were going to put pineapples on it. That's just
Oh, no. That's a whole different pizza. That's not a quantum pizza. That's a general relativistic pizza.
I feel like we really learned a lot about Dr. Liu here. We learned infinite amounts about Dr. Liu here. Smitty, you want to take this next question?
Sure. Max in Austin asked, if quantum mechanics had a mascot, what would it be? Schrödinger's cat, a particle, or something else entirely?
It has to be Schrödinger's cat. Schrödinger's cat was an idea, and many of you have heard of this term before, right? But it was an idea put forth a long time ago by one of the pioneers of quantum physics. His name was Erwin Schrödinger. He was discussing with Albert Einstein some of the strange consequences of the mathematics of quantum physics, which at that time was just in its infancy. And he basically said, you know what? You could think of a weird situation where you need to superimpose a dead cat and a living cat. You create some sort of strange experiment where a cat could be alive and dead at the same time. That's became known as Schrödinger's cat. Now, what he was saying was, look, guys, we all know that something is either all the way dead or all the way alive. There's no in between, right? Now, I can use quantum physics, however, to imagine a scenario where until you looked carefully with an experiment, the cat is both alive and dead at the same time. That makes no sense. Obviously, quantum physics has a lot to learn. It's still not quite there yet. Well, nowadays, we do think that indeed there could be superpositions. We might not be able to know whether the cat is alive or dead, or if it's 60% alive and 40% dead, right? That idea has really led to a lot of imagination and creativity about quantum physics and our exploration of the physics of the very small and the basics of all of our entire universe, both the tiny and the gigantic. So Schrödinger's cat, totally Schrödinger's cat.
Excellent. Well, we really appreciate you addressing our listener questions, Dr. Liu.
Oh, my pleasure.
And I'm going to turn it over to CJ now.
Yes. Well, goodness, I learned so much, as I always do every time you come on our show. So we thank you for that. Is there anything that you would like our listeners to know about yourself, where they can find you or your book before we sign out for the night?
Well, I'm on various social media and places like that under the handle The Luniverse, THELIU Universe. So you can find me on pretty much every social media platform, YouTube, Facebook, also places like that. And that will give you a sense of what I'm doing in terms of all of this good stuff that has to do with the book and so forth. I want everyone to know that the research that I'm doing right now is including work on the Rubin Observatory. And I want you to know that because in about a year, you guys are going to hear that the Vera Rubin Observatory is beginning its operations. It is an amazing telescope project combining with big data and amazing technology, which on its first night will gather more data than all the rest of the world's telescopes put together.
Whoa.
It is an
That is
amazing,
impressive.
it's amazing, wonderful project. It's been decades in the making. I've only been involved with it for about 10 years or so, but long ago, back in the late 90s, I was involved in some of the conversations. There were scientists like, hey, let's build this amazing telescope system. We don't have the technology yet, but let's start planning. And I just was able to be in on that a little bit. And then 10 years later or so, I was asked to be on the science advisory committee for that program. And I was like, wow, you guys have made incredible progress. And now we are about a year away from it beginning science operations.
That's
Everyone
incredible.
look for that. Yeah, it's wonderful.
How do these telescopes deal with all of the extra stuff that's in our skies right now?
That's actually a challenge to be
Space
discussed,
blanket, yeah.
right? We have an entire subcommittee,
Right.
right? As you can imagine, there are hundreds of people involved with this observatory. There's an entire subcommittee that has been talking with SpaceX and other companies. Amazon is putting up a satellite of it, a constellation of its own. Other companies are thinking about doing that as well. And what's happening is that Starlink, for example, is going to produce huge streaks of light
Right.
going through these images pretty much every few minutes. And that
Oh,
will really degrade the overall productivity
Yeah.
scientifically. So there have been some things discussed. Already Starlink, for example, has agreed. I don't know if this will happen right away in its next generation of satellites or whatever, but they're going to paint the satellites a different color than they originally planned. They're going to turn the satellites operationally a different angle compared to the ground than they originally planned. And hopefully that'll mitigate a lot of these issues. But that is a topic for discussion, right? We want to have internet available to everybody all the time, which is a good thing. We also want to be able to study the universe. And
Yes.
so how do we intermingle all these things? Great question, CJ. In fact, heck, maybe, all of you out there who are listening, think about those kinds of questions. In fact, the questions I answered are just awesome. I want you all to sort of just remember that the questions we have to answer are the ones we have yet to ask. We always should remember that. And
Yes.
all of you keep asking questions. There are some answers in this particular book that just came out, but there are many, many more that we don't have the answers to. Maybe someday you guys will be the ones who figure the answers out. Just keep asking those questions.
Yes, just a few thousand answers in this book. You also should know that Dr. Chuck Liu sometimes sings on his social media platforms. You don't want to miss that, so be sure to follow him. And he is a professor, so those of you that are lucky enough to be in his class this upcoming semester, May you really take everything he has to offer and run with it. So we are grateful for your time. Tim and Smitty, thank you guys. It's been a wonderful show once again with our all-time favorite guest, Dr. Chuck Liu. And shame on us for not having a Chuck clip in the intro, in our intro. How did he not make his way in there? Maybe it's because our tech used to be so bad and we've just gotten better clips since then.
We fired that intern that was responsible for that video.
Oh, you guys are so sweet. It's such a pleasure to be on with you all again, and I hope I do it again real soon. Thank you so much.
All right. Thanks to all of you for joining us on this incredible journey tonight through the quantum realm with the one and only Dr. Chuck Liu. You know, quantum physics challenges our understanding of reality, opening doors to possibilities we could hardly imagine. As we have explored tonight, from the mysteries of the atomic world to the vastness of the universe, quantum physics continues to reshape our future in profound ways. Remember, the quantum world is all around us, influencing everything from the smallest particles, as Dr. Liu says in his book, to the stars above and other universes. If tonight's conversation has sparked your curiosity, just like he was just saying, be sure to check out his new book, The Handy Quantum Physics Answer Book by Dr. Charles Liu, for even more mind-bending insights. Let's remember, folks, until next time, get off your screens for a little while. Head out into the woods, look up into the skies. You may not see a Bigfoot, you may not spot a UFO, but you might just find yourself out there. Smitty?
I was just going to say, Chuck Liu is my favorite Chuck, and that's even counting Chuck Norris. So,
boom.
You're over Chuck Norris there.
Oh,
so
thank you.
We really, really love every time you come on the show.
Honey had Heart shootout.
You're just an amazing guest, and we're so grateful for all that you do. And the way you explain things is just like phenomenal to me. You speak where everyone can understand it. And as a teacher, I appreciate that because I try to speak to where my students can understand the concepts that I'm talking about. And I think that's great. Where I know you could speak way over our heads, you put it down there where we can understand it. So we really are grateful for that. And we're grateful for our listeners. And remember, be happy, be strange, and listen to all things unexplained. Good night. Thank you for listening.
Anomicon.
Thanks, everybody.
Anomicon is a virtual conference.
Check
on
out Ryan
everything
Sprague's
anomalous, live
Anomicon,
streaming
folks.
on YouTube, Twitter, X, and on Twitch. Join us on September 1st and 2nd as over 24 speakers give presentations on everything from UFOs and aliens to ghosts and the paranormal, from Bigfoot and lake monsters to witchcraft and the occult. It's all happening at Anomicon, and most importantly, it's completely free. To learn more about our speakers and the event, visit anomicon.com. We'll see you on September 1st and 2nd for Anomicon.
All things unexplained.
What's your hot take on Travis Taylor?
I've got an exclusive for you guys if you want it about the Alaska.
We do.
Okay.
Dr. Taylor was revealed to be the chief scientist of the UAP task force with the Pentagon.
So some of that, I think, sir, we'll save for closed session.
All Things Unexplained is free to watch on YouTube and listen to wherever you get your podcasts. If you would like to support our show, you can visit our YouTube store. Additionally, you can find us on Venmo under All Things Unexplained. Be sure to check out our website, allthingsunexplained.com. All proceeds from the sales of Dr. Mounce's books on Amazon and Audible also go straight to our show.